There are common activities in analysis and design of a software system. First, the basics of requirements analysis explains how to assign responsibilities to objects. Object design in view of known design patterns follows next. What does it mean to have a good object design? Well-designed, robust, and maintainable software means knowing how to think considering objects. Using standard diagramming notation, the UML, is also critical to the design process. How should responsibilities be assigned to classes of objects? How should objects interact? What classes should do what? These are critical questions in a design of a system. Software design is strongly related to prerequisite activity of requirements analysis, which includes writing use cases. Use cases are not object-oriented. At the same time, software design, including requirements analysis, are repetitive activities. Other important skills involve user interface and database design. However, our introduction emphasizes object-oriented analysis and design. Assigning responsibilities to software components is critical to proper design. Responsibilities represent fundamental abilities of the objects. Responsibility strongly influences the robustness and maintainability of software components. So assigning responsibilities is vitally important skill. This principle also helps to improve usability of objects. Analysis emphasizes an investigation of the problem and requirements, rather than a solution. For example, if new computerized library is designed, analysis helps to understand its future use. Requirements analysis is an investigation of business requirements. Next, object analysis is an investigation of the business domain objects. Design emphasizes a conceptual solution to fulfill requirements, rather than its implementation. An example would be a description of a database schema, or a description of software objects. Ultimately, design gets implemented, and software is written. During object-oriented analysis, there is an emphasis on finding and describing the objects, or concepts of problem domain. For example, in the case of the library information system, some of the concepts include book, library, and customer. During object-oriented design, there is an emphasis on defining software objects and how they collaborate to fulfill the requirements. For example, in digital library system, a book software object may have a title attribute, and get chapter method. Finally, during implementation of object-oriented programming, the design objects are getting implemented by a team of programmers. So, concept becomes a book class in the source file of the application. Requirements analysis include a description of related problem domain processes. The processes can be written as use cases. Use cases are not an object-oriented artifact, they are simply written short stories. For example, consider brief version of the play dice use case. Its name is play dice. The player picks up and rolls the dice to begin. If the dice face value total 7, player wins. Otherwise, player loses the turn. The application domain involves concepts, attributes, and associations between those. Classification of these objects is the next step. For example, the dice game could be represented by the following object diagram. This model illustrates the noteworthy concepts: player, die, and dice game along with their associations and attributes, are the concepts of business. Note that a domain model is not a description of software objects. Model is a visualization of concepts in the real-world domain. Object-oriented design is concerned with defining software objects and finding collaborations between the objects. A common notation to illustrate these collaborations is the sequence diagram. It shows the flow of messages between software objects, and therefore, the invocation of methods. Sequence diagram illustrates messages sent between software objects. For example, assume that we need a software implementation of the previously described game. The sequence diagram illustrates the essential step of playing. The system sends messages to instance of the dice game, followed by messages to instances of other software classes. In real-world, player rolls the dice to play. In software design, it's the dice game object that rolls the dice to execute a use case. Dice game simply sends messages to instances of other objects. Software object designs and programs do take some inspiration from real-world domain, but they are not direct models or simulations of the real world. In addition to a dynamic view of collaborating objects, shown in sequence diagram, it is useful to create a static view of the class definitions. This can be accomplished by a design class diagram. The diagram illustrates the attributes and methods of classes. For example, design class diagram shows the dice game model that succeeds the sequence diagram. Since a play message is sent to a dice game object, the dice game class requires a play method. Class die requires two methods, a roll, and get face value. In contrast to the business domain model, this diagram does not illustrate concepts of real world. Instead, it shows the software classes. The dice game is a simple problem, presented to focus on a few steps and artifacts in analysis and design. To keep the introduction simple, not all illustrated UML notation was covered by us at this time. Future discussion will cover more analysis, more design, and other artifacts, providing closer detail. The Unified Modeling Language is a language for specifying, visualizing, constructing, and documenting the artifacts of software systems. It is also language of business modeling and other non-software systems. Object Management Group is an industry standards body. It is guiding future development of object-oriented technologies. Unified Modeling Language has emerged as the standard diagramming notation for object-oriented modeling in business and in commercial software development. Design work includes drawing the diagrams and composing design notes. Initial diagrams can be scribbled on board and captured on digital cameras. Cycle includes design, integration, implementation, unit testing, daily builds, further system testing, and stabilization of the partial system. Other activities include demonstrations and evaluations with customers, and planning for the next iteration. Although there is a rush to code writing, the design step takes place first, initially. It is relatively short, not too long before programming is started. The result of each iteration is an executable, but incomplete system. It is not yet ready to deliver into production environment. The system may not be eligible for production deployment until after a few iterations. Perhaps 5 to 10 iterations may take place before the deployment. Benefits of iterative development include early rather than late mitigation of high-risk challenges, early visible progress, managed complexity, short and simple iterations of development, small steps, rapid feedback, and adaptation are central ideas in iterative development. Incremental approach helps the team of developers to constantly learn new things. In accordance with International Object Management Group effort, design activity includes the following modeling steps. Business model. Requirements. Requirements stage is also known as a use case model. Analysis. Design. And, finally, implementation. Business model includes business domain objects. When engaged in large-scale business analysis, or in business process engineering, this includes dynamic model and business process across the entire enterprise. Analysis for an application, such as defining use cases and identifying non-functional requirements, is included in requirements model. Analysis model covers behavior modeling in a format of state chart diagrams. Unified modeling language state chart diagrams illustrate the events and states of things. The state chart diagrams demonstrate system events in use cases. This includes transactions, use cases, and people. Consider state chart diagram for telephone communication. The state chart diagram shows the life cycle of an object, what events it experiences, its transitions, and the states between described events. Design model covers all aspects of design, including the overall architecture, objects, databases, networking, and other parts of the software system. Implementation means programming and building the system, but does not include the deployment. Our semester-long project includes the implementation model. Completion of fully functional software system concludes previous stages of application design.